Okay, so now we're going to talk about p-value, and it's really important. This is different from proportion or anything else. This kind of mirrors what we do in hypothesis test. So we've written our hypothesis, we've run our data, we've found our correct test to run as well, but then we're given a test statistic and a p-value. For this class, as important as the test statistic is, we're also going to talk about that p-value. That p-value to me is everything. So let's look at it. So when you're using sample data to calculate the actual probability of getting the test results, we call that the p-value. So the p-value is the probability that if the null hypothesis is true, the results from another random sample will be as extreme or more extreme as the results obtained from that given sample. So what's that mean? That means that I could redo, if I run this test again on another sample, I think I will get the same results. Nothing is cut in stone with stats and stuff. And, unfortunately, you got to be careful of what, when you do a sample and you do something, yes, you hope that it will go across to the population, but you're making the assumption that what you did was correct. You followed every rule, and that if you found another sample like this, it would give you the same results. So a large p-value calculated from the data indicates that we should not reject the null. That means we're keeping it. So the smaller the p-value, the more unlikely the outcome, given stronger evidence against the null. Then we would reject the null if the evidence is strongly against it. If you're not understanding this part, that's okay. We're going to keep going. All right. Here's your decisions and your conclusions. Okay. If the p-value is less than or equal to the level of significance, remember alpha is your level of significance, you reject your null. So again, if your p-value is less than or equal to the level of significance, you reject your null. That means that the null hypothesis is false and your alternative hypothesis is true. If your p-value is greater than your level of significance, you fail to reject the null. That means your null hypothesis is true and your alternative hypothesis is false. I'm going to show you a really weird way that I remember this, and it might help you because you're like, how am I going to remember all this? Okay. This is really stupid. I understand. But just go with me on this one, okay? I know you're like, what are you doing? But watch. Okay. People who are eaten by fish, are effed. And you know what I'm talking about. Okay? So, people who are eaten by fish are effed. So that means you're getting eaten by a shark. There's not a lot you can do. You're kind of effed. So that's the way I think about it. People who are eaten by fish are effed. It's the same as the P is greater than the alpha. You fail to reject the null. That's how I think about it. I know it's kind of crazy, but that's the way I think about it. And instead of having to memorize this table here. So look at this table. Whoa, it's a crazy table. Okay, so if the p-value is less than the level of significance, you reject your null. Excuse me. You reject your null, but you don't reject your alternative. If your p-value is equal to, same thing, reject your null, but don't reject your alternative. If the p-value is greater than the level of significance, you don't reject your null, but you reject the alternative. Okay, so let's think about the meaning of the p-value. So a data analyst or anybody else should be more confident that he made the correct decision to reject the null hypothesis with a smaller p-value. So again, that 0.001 is a lot smaller than that 0.04 if I'm using a 0.05 for my level of significance or for the alpha. Similarly, 0.4 opposed to a p-value of 0.056, if the alpha is 0.05 less than that number, I would be more confident that I've made the correct decision and not rejecting the null. So think about it this way. The smaller the p-values are as they keep going, the more confident I am in rejecting the null. The bigger the p-values are, the more confident I am in not rejecting the null. All right, let's do some examples. Example 1. The p-value is 0.046 and the level of significance is 0.05. I added extra zeros to make them look easier because see, If I have the 3 decimal places here, it's easier to compare. So since 0.046 is less than or equal to 0.050, I reject the null, which means the null is false and the alternative is true. Let's do example 2. The p-value is 0.20 and the level of significance is 0.10. Since 0.20 is greater than 0.10, I fail to reject the null, which means the null is true and the alternative is false. Right? Last 2 examples. The p-value is 0.10 and the levels of significance is 0.10. All right, since 0.10 equals 0.10, I reject the null, which means the null is false and the alternative is true. So example 4, the p-value is 0.45 and the level of significance is 0.10. Since 0.45 is greater than 0.10, I fail to reject the null, which means the null is true and the alternative is false.